Hello, game freaks, and how are you all doing? So, in the last video, we made this very simple RPG character animation using JavaScript. Now, in today's video, we will be adding one more feature to this one that we are missing currently, and that is right now our character moves in four directions, and which is absolutely fine. But what I want to do is I want to add some sort of a diagonal movement also. So, let's say when we are pressing S and D together, so either we are moving right or we are moving down. So what I want to do is we should be able to move diagonally somewhere in the southeast direction, let's say. And so in the four diagonal directions, we want to have such kind of a movement. So let's see in our code how we can have this nice little addition. So right now we have one HTML file. We have declared a canvas and we are connecting to a script.js file. And there we are first of all getting our canvas and we are getting some sort of a context from the canvas to draw our images and everything, of course. We are setting some width and height, and below we have some keys WASD for the four directional movements, and all of these are set to false. Now they will become true when we are pressing the respective keys. So all of these keys will become true, and when we are releasing the keys, they will become false once again. So depending on this, we have four kinds of movements. So what I want to do is, let's say when we are pressing both keys, so both keys will become true, and then we want to have some sort of a diagonal movement instead of either moving sideways or up or down. So how can we do this thing? So if we go a little bit up, we have the game loop, and inside we are doing an update player and a draw player, and we are repeatedly calling the game loop, and this is how we are getting the animation. Now, in our draw player, we are simply drawing our image. So for walk left, we are flipping. So if we take a look at the sprite sheet, so we don't have a left animation, we have a right animation, and we are flipping it for the left animation. So in our walk left, we are flipping it. Otherwise, we are drawing the player as it is. And depending on our frames, so we are able to have a good animation. Now, where are we getting our frames from? We are getting our frames from our update player, and here we are setting our frames depending on the interval and many things. So our draw player will mostly remain as it is because it's only drawing the player. So in our update player, let's see what we can do to add our diagonal movement. So right now, if we analyze the code, we have a determine direction and move. So here what we are doing is when we are pressing the W key, and we are also checking that the player is not out of bounds, like it's not outside the canvas or something like that. So in that case, what we are doing is we are changing the value of the player y by the value of the player speed. Now these are some things that we have declared at the top. So in the player, it has one x and y value. This depends, like this is where the player is in the canvas in the xy coordinate. The player has some speed and some frames and other things. So whenever we are pressing W, we are like subtracting the player speed from the player by, and hence we are able to move up. We are also changing the player direction to walk up, and etc. etc. Many other things we are doing. And in normal situations, we are having an idle. And this is how we are having this animation that we are able to see right now. So let's see how we can add the diagonal movements. So there must be a way to identify when we are pressing both the W and the either A or D. So let's see what we can do. So we have a player dot moving as false here. Now below we will add two more variables, move X, let's set it to 0, and a move Y. So when both move X and move Y have a value, we will have diagonal movements, and that is something we will define here. So let's say when we are pressing the keys dot W and we have, let's say this one, when it is out of like not out of bounds, so when the player y is greater than 0, which means this is not above the canvas or something like that. In that case, we will do when player dot y is greater than 0. In that case, so we can consider this to be an upward movement. So we will do this thing, move y minus equal to player dot speed. So whatever we are doing here, we decided to do above. Now why so? That is because here now we can only do one thing. We can simply do if move y is less than 0, In that case, I will change my player direction to walk up, and the player dot moving will remain true. There is so player dot moving here is false. So we need to do the player dot moving to be true. Uh, so this is something that we will. So this is something that will have happen every time apart from the idle. So what we can do here is before doing everything, we can do a player dot moving to be true, and we can separately handle our idle case. So this is something we can do for now. So similarly for all the four cases, we will then check if keys dot s and player dot y is not out of bounds. So for the downward case, it should be less than canvas height minus our player height. So the player height we are taking as a scale height. And in this case, what we will do is we will add the move y. So move y plus equals to our player dot speed. Then what we need to do is if our keys dot a is pressed, in that case, what we will do is we will also check it is within bounds in the x direction. So player dot x should be greater than 0 and move x should be subtracted by the player dot speed. And lastly, we need to check for the keys dot d. So keys dot d, and this should be if. Some typos I'm having. And then we need to check that the player dot x is not out of bounds on the right side. So it should be less than canvas dot width divided by scaled width. Yes. And in that case, we will have a positive value of the move x plus equals to our clear dot speed. Now, why are we doing this? Our movements in the four directions are already good. And that is because now we are actually changing all of these values into a move x and move y. Because when we have a single value of move x and move y, it is a walk up, walk down, walk left, or walk right. But when we have both the values of move x and move y, that will become a diagonal movement. And that is what we will apply right now. So for the diagonal movement, we need to do a few things. So first things first, we will check if both our move x, so this should be move x, is not equals to 0 and our move y is not equals to 0. Is not equals to 0. So the difference between these two things is, so here we are checking if we are walking up, otherwise we are checking if we are walking left. So there is an else if. But here two things can be set at the same time. So let's say we can have a keys.w pressed and a keys.a pressed, and in that case both the values of move y and move x will change. And when both of these values are not equal to 0, we will have some sort of a diagonal movement. And that is what we are doing here. So we will have a diagonal speed, and here things will get little bit mathematical. So we have to use the Pythagoras theorem to get our respective speed. So we have a player dot speed, and this should be divided by math dot square root of 2. Now, why we are doing this, it will be clarified in a moment. So this is a diagonal speed. So this is the angular speed. But when we are drawing our character, we need the value of x and y. So we cannot like simply use the diagonal speed. So what we have to do is now we have to get the separate values of the move x and move y. So what we need to check here is the direction first of all. So if the move x value is greater than 0, I will have my diagonal speed. And otherwise, if the move x value is less than 0, then I will have a negative of diagonal speed. This is simply for adjusting the directions. So, okay, so our upward movement is little bit jeopardized here. And the reason is we have changed some things of at the top, but we have not really changed here. So yeah, we will see that. But this is for adjusting our directions. So which direction our player is moving. So depending on that, we will have either a positive or a negative value of the diagonal speed. Okay, that's fine. And similarly for the move y, we will check if the move y is greater than 0. Then again, we will have a diagonal speed. Otherwise, we will have a negative diagonal speed. Now, if you look correctly, what we are doing here is when we have move x square plus move y square, when we are having a square, we are actually getting the player speed, and which is actually what we need. So whenever we are having a diagonal movements, our x direction and y direction speed need to be adjusted, and this is the adjustment, and this is something that we are doing according to Pythagoras theorem. A square plus b square equals to c square for a right angle. So I hope you understand what we are doing now. But yeah, in short, this is what we are doing. Anyway, and then what we need to do is, so for the player dot x, we need to add by move x, and for the player dot y, we need to add by move y. Very simple stuff. Now, after doing this, we are no longer changing what we are pressing directly. We are doing these things, so these things will be taken care of by the move x and the move y. So what we will do now is we will do things little bit differently. So here we will check first of all if the value of move x is 0 and the value of move y is also 0, then what is this case? This case is our ideal case. So what we will do is player dot direction, player dot direction, not Dore or Doraemon. So this is ideal case, and in this case the player dot moving is false. Now in every other case the player dot movement will be true. So we'll add an else case here, and inside the else case we will make the player dot movement to be true. So in the else case previously we were checking it to be idle and the player dot moving was false. For every other case it was true. Now here we are just handling it differently. And now comes the most interesting part, and that is handling player movements. So we will have two kinds of movements. One is diagonal movements, another one is straight movements. So we already have little bit of idea how this kind of movements are working. So for example, for the walk up, we can now simply do this. We can check the value of move y. If this is less than 0, we will simply change the direction to walk up. The remaining things will be handled on its own. For example, we are already changing the values here. Now, else if we need to check the walk down. So walk down will be simply if the move y is greater than 0, we will write the player or direction to be walk down. Now, we must remember that this is only like taking care of the animations. This is not doing much. How our character will move, like the values, that is already being taken care of. So this is what we are doing it for. So where we were. So we are doing a walk down. Now else if we will check if our move x is less than 0, then what we have a walk left. So player dot direction. This is our walk left. And lastly, we have the last case, else if our move x, if this is greater than 0, then we have a player dot direction to be, this is walk right. Now this is for our straight movements. Now comes our diagonal movements. So for our diagonal movements, we need to check two things. So if move x is greater than 0, let's say, and move y is less than 0, so what is this direction? So move x is greater than 0 means this is the right direction, and move y is less than 0, that means this is downward direction. So this is kind of like moving towards the south, east, something like that. So in that case, what we want to do, so let me do a player dot direction to be walk down. So let me check once again. And also one more thing that we need to keep in mind, that is, um, we cannot have two ifs here because a player moves in one direction at a time. So only one of these cases should be triggered. So here it should be an else if, and it should be continuation of this one. So let me just keep the else part here. So I have to remove the straight movements. So yes, so let me keep it here. And here I will simply write straight movements. So let's see um, if our diagonal movements work or not. So four direction movements are working fine. I think there is a little bit issue with the speed, so we'll check that. So yes, something is working. So yes, little bit of diagonal movements we are able to do. Okay, so there is some issues happening now. Huh? So left, right, up, down is fine. Okay, so it's not fully diagonal in that sense, but something is happening. Yes, so something is happening, that's for sure. So okay, anyway, we are checking the move x and move y. So move x um, will have a value depending on what we are pressing and whatever. So yeah, so let's complete it and then we'll see what is the behavior. So if else if let's say our move x is less than 0 and our move y is let's say this is also less than 0. So both less than 0. And in this case, we will have a player dot direction to be again a walk down. Now else if we will have the move x is greater than 0 and the move y is also greater than 0. So we are basically taking all the four cases in the four combinations. So player dot direction in this case will be walk up. So we don't have diagonal animation, so we are reusing our walk up and down animations, that's all. So in this case, move x should be less than 0 and move y should be greater than 0. And again, we will have a player dot direction to be a walk up. Now, all of these things are done. And then what we have is, okay, so the issue is this. So this is also active. So this should not be active. So let me comment it out for now. And then we are taking the frame Y depending on the direction. And now what is the frame Y? The frame Y is basically the frames for the animation. So from the animations, we are just choosing something. And accordingly, the frame Y is being taken. So 1, 2, 3, 4, or whatever. It is basically the row number. So now I believe our movements will be much better now. So let's see what we have. So left, right is fine, up and down is also fine. So the reason previously the speed was a little bit different was because two kinds of speeds were adding. So here also another kind of speed was adding. And so I believe the issue was there. Now for our diagonal movements, oh, okay, I think there is some issue. So the directions are a little bit off. Okay, so sometimes it happens. We miscalculate, like sometimes we get the wrong idea of which direction is where. So yeah, so we can get this little bit of ideas also by trial and error. So now everything will be fine. So left, right, up, down, and this is how our diagonal movements will work. And now I hope you understand what the diagonal speed is actually. So if we have taken the player dot speed to be 3 for the diagonal also, like 3 and 3 for the x and y, then the diagonal speed will be much higher. So that is not something that we want. We want the player speed to be maintained in all directions, and so we have taken the diagonal speed. So this is the diagonal directions, and this is how our player will move. So yeah, so a nice little addition to have for our sprite, I will say. And there are also a lot more things that we will see regarding how we can make a good RPG game, possibly some sort of a game engine only, where we can drag and drop. So let's see. We will make lots of videos on this one. So that's it for this, folks. Now, if you have learned something new in this video, make sure to like, share, and subscribe. It helps me grow the channel, and I can make a lot more videos like this one. So that's it for this, folks, and I will see you soon with another very interesting video. So, see ya.